Now, without any further delay, I would like to turn today's meeting over to our presenter, Adrian Hammond. Adrian, you now have the floor.
Thank you, Jana.
You're welcome.
So, thank you for attending our webcast today on Coded UI in Visual Studio 2012. My name's Adrian Hammond and I work for Testhouse based in London. So I'm going to talk today mostly about data driving and a little bit about how we can improve our tests after we've done some data driving. But first, a bit about Testhouse. Now, many of you have seen these slides on previous presentations by my colleagues, so I'm not going to read them in detail, just show them quickly. We've got a whole variety of customers. Here's just a few we've pulled out, but a lot of others in the banking sector, in finance and in retail. We've got various qualities which we believe are good reasons for you to think about Testhouse. And for a variety of reasons, we think we can add value to any work that you might need to be done. So data driving, that's the presentation today. It's similar to iterating a standard test case. We might do data driving because we want to check boundary conditions to make sure that our code works properly for normal values and also for values that are at the edges of the valid range of values. We also want to make sure that it works correctly for values outside, that it gives the correct error messages or something. And we might do that by having two sets of tests, one for the out-of-bound conditions and another test for the inbound conditions, or we might merge them together, but that would make the test more complicated. So data driving is about running one test with many different sets of values, and we can run these sequentially or in random order. The data is provided or linked to the test cases by the data source attribute, which we specify in our source code. And having linked up the data source, we then get values out of this data source via the test context class, which has a data row field. The sort of data that we can, the sources we can have for our data are most database types that are available on our computer. Anything really that's accessible via an ODBC driver. So that's all the standard databases like SQL and Oracle, but also from our spreadsheets, our XLS files from Excel. Or we can put our data into simple text files, which can be XML format or CSV format, and I'll be demonstrating CSV format in later slides. So here I have a video which I will show. To find the right button on my screen, excuse me. So we have to replace the test method attribute in our class by this, and these are the sort of lines that we would use for different, I beg your pardon, something's not happening. I believe we have a blank screen. Now it's coming up. Let me start the video again.
Oh, Adrian, I can see it just fine.
Oh, I beg your pardon. We've got a monitoring computer here and it was not showing the screen okay. So I've reset the video to start again.
Wonderful.
So, okay, we replaced the test method attribute on our test class with some code. These lines of code are available on the Microsoft website as examples of the sort of code you need for test driving, and this is the line I'm going to be using for this particular CSV case. So we just put that at the top of our method. Note it includes the test method. attribute itself. Inside the data source, we have to repeat the file name 3 times and also describe other aspects of it. We need to add the data source, its existing item, into our solution. Here it's on the desktop of this computer, so we just have to go and find it and reveal all the file types on there, and then we can select the test data CSV file itself. So that comes up and appears in our Solution Explorer, simple file containing a few lines. We need to adjust the properties, particularly the copy to output directory property. Copy if newer probably works. I'd like copy always, just in case. The files are normally smallish and space is not a problem, so copy always works. And then, having connected the file, we need to actually make use of the file. So it has, here's some lines I've made earlier, some assignment statements to get the file, the data out of the CSV file. So we just have to put those before the methods that use them. They could go in line, interleaved. It's a matter of personal choice whether you want to put them all before or interleaved. The data is read out of the test context and the data row of that. It's like an array but indexed by names of the fields in our spreadsheet. And it's worth putting toString just in case. And then these values are written into the methods, the classes of the methods for our action methods. The params added to the method name for values that are put into methods, and the expected values for the results. So we can run our test, and it runs the calculator with all the various things we've typed in. And after a moment, it stops and says it's failed on this set, which I expected, just to show things. So I've got 2 rows that pass and 2 rows that fail. So when we look in the data file itself, we get one confusion. Row 0, data row 0, is the second line of the file. So the blank line is row 2 and the 8 comma is row 3. So it says that rows 0 and 3 have passed. That's row 0 and row 3. Here it says row 2 failed, value cannot be null. It's trying to pick a value out of that blank line and it's failed. So we'll get rid of that. And the other one says the numbers were not as expected. And when we look indeed on row 1, we see that 15 divided by 3 is not actually 7, it's 5. So if we correct that, and then we can go off to the test again. Ah, yes. You'll notice the plus sign is wrapped in curly brackets. That's because of how these files are interpreted. It's sent through the send keys method, and that interprets some things, particularly the plus sign, as a shift character. We want to cancel that interpretation, so wrap it in curly brackets. Also, be careful in these CSV files and other data sources. Things like telephone numbers, which often have a leading 0, tend to have that 0 removed by the code that interprets these text areas. Just the same as in your files, when you type in telephone numbers, sometimes they have leading 0s taken off. Also, be careful with numbers or text with hyphens in it or colons in it, because they can be interpreted as dates or as time. So when we run this again, it should all pass. and that's it, all passed. So back to my presentation. So we can do more with data driving than just simply what I've shown you there. So I'm going to show you two particular styles. So here I've got my Visual Studio running. Now, in the basic data driving, this was the data file I used, and operates through this test method. So what I'm going to do is add some more into that. So what I've done is I've kept the same data values here, but I've added a command value to the spreadsheet, so that if the command is calc, it will repeat the test which I'd used previously. And I've added other command values here. So for example, to multiply, I'll just take these numbers. Note that I've left the upper column blank, so because I don't need it for these tests. And now with this command-driven style, this code is very similar to what I had before. It pulls the the numbers for my two input values and my expected result. It launches the calculator. Finally, it does the calculation and checks the results. But in the middle now, it's pulling out of my data row the command and passing that as a parameter into another method. And this method switches between different blocks of code based upon that command value. Now, perhaps you'll say this should be written differently, but it's to show you that you can use commands and switch statements and if statements to read values out of the data source and switch between different bits of code. In this case, I've encoded these buttons here as particular methods, so if I go to their definition, for example the multiply, it's quite simply recorded as a mouse click upon the multiply button, just like any other mouse click is recorded. So here I've recorded each of the operation buttons as a separate action, and I can call them as I need. So I'm using my command parameter from my CSV file to call into different pieces of code according to need. And finally, I've got a default case which says if the command is not recognized against any of these options here, then fail the test with the suitable message. Now what I've also done is here I've added one test into my thing just to make sure the test suite is working right, that when the command I'm using is not understood by the system, it will fail correctly. It will detect that there's something wrong with my test suite. It's always worth, when you're writing tests, just checking that the failure conditions are properly detected. It's simple, this. It's nice and simple. We had a website which was checking on travel details, traveling by air from one place to another, leaving on at one date and returning on another date. And the website in particular had one of these clever date choosers on it, which didn't allow the input of bad dates. So we don't have that luxury in a CSV file, so it seemed necessary to check that my data was valid before presenting it or trying to present it to the website. So from this, I produced this large file, which has the data down the bottom here for the valid use of the website, but a whole series of values here which say, what happens if my data doesn't have a leaving from? What if it's not going anywhere? What if various pieces of the dates are wrong, or they're in the past, or they're in the wrong order? So to accommodate, what I did was raised assertions when these different dates were wrong, and this is the name of the assertion. Now this text looks horrible, as does this, and what I did was I ran the test and I copied it from the error messages that were produced, checking that it was as I expected. And then the code I wrote to support this was in the suspected failures area. Here is the action to actually run the test, just within a normal test method that's data driven. So this runs the test, but before I ran the test, I pull out of my data source those two values about exceptions, and then run the test. If the test continues to this point of code, I know that no exception has been raised. Alternatively, if the code carries on through here, some exception has been raised. So at this point, if no exception has been raised, and these two items were both blank, both empty, then the test has passed because I wasn't expecting any exception. On the other hand, if either of them is not blank, then I was expecting some kind of exception from this test, but I didn't get one. So this test has actually failed. Seems confusing because I didn't get an exception, the test has failed. But if you pause for a moment and think about it, it does make sense. Down here, given that I was using the real exception name here, I've got to take a very general exception catcher here, and then I'm comparing the name I get and the message type. If they're both as expected, as in the data source, then even though this test threw an exception, it's the one I expected, so the test has passed. And I separated out the two cases of the exception type and the message not matching, and if either is wrong, then I just throw the exception on to the standard test handler to say this this test has failed. So let's have another look here. What I've taken is the name of the exception and the full message about the exception, and just done equality checks on these things. Note that if your test is more complicated, we could be doing an assertion on values which our program is generating and putting on the screen, or our website under test is developing and showing on the screen. Then you might not be able to say a message quite like this, so you could have something more like a regular expression here to check that something is equal to or matches the thing, and then this which was it? This equality test has to be more like a regular expression match than a strict equality test. So that is some ideas on data driving there. So what I also wanted to talk about was how can we improve our tests and add more useful information to them and make them run better. One thing we can do is catch more images as the test is running to show the website at different positions during the test. By default, Coded UI records a screen image when the test fails, but that might be too late for some tests. So we can capture the whole desktop as an image, or we can capture the application, and you can use more clauses within the image 2 line there, so that you can get down to small details of your whole application on the window. Then you need to save the file away and give it the file name there, and then using the test context.add result file, specify the name of the image you saved, and that file will be added to the results of your test. Now you can actually add any kind of file, so you could, for example, be creating files as part of your application, and you'd be able to we've just had an emergency vehicle go past our office. Sorry about the noise. You could add any type of result file there, and your application could be generating files as it goes, and part of the test would collect those files and add them to the results. You could be adding logging information onto a special purpose logging file and want to add that. So we can add any type of file to our test results. Just be cautious on directory names and file paths when you're writing and using these routines. And remember that within the test context there are several properties which contain the word directory in their names, and these can be very useful in finding the right file or the right path in the right place for our files. Another thing that happens, it's nice sometimes to create a separate account of tests passing and failing and what their outcome was. Now at the bottom of this screen you'll see test context.current test outcome. This is an enumeration type within the test context. It has values including those on the far right. So we could write that out to some log file as our test is going. That on itself is not very much information. So it'd be quite easy to add into our data for our data driving something like a test name or some other description of our test. And then we can collect that in the test method and write that out to this logging file. And some people like to know the data row number of their test. Now clearly you could do this by counting test methods as they execute, but that only works for sequential tests. There's this nifty little piece of code which is in the middle of the screen highlighted in red, actually evaluates the data row number that is being executed at the time. So in the test cleanup method we can write these 3 pieces of data, or more or less. There's many possibilities of what you could write there. In terms of what is out file, I wanted to be very unspecific on this slide and let you figure out the sort of output file you want for this information. Possibilities do include the console or the debug log, but they seem to get data separated over several different result areas, so you might like to create a special purpose file for the test that's created at the beginning of the test and logged to as the test runs and then closed at the finale. In terms of making the tests behave better, we can quite easily see an application has a fault and it just sits there spinning forever, and our test waits for something which will never happen. So it's good to think about timeouts. Now in the test settings file, you can specify timeouts per test and also across the whole test suite. So it's worth investigating those. Several of the methods that you call in running your tests actually have timeout options as well, so it's worth investigating those. And of course, it's not just the application that can have faults. The test suite itself, when you start having more complicated things in the test suite, you start doing clever things with data driving, for example. The test suite itself could have faults, and so whilst the application is perfect, the test suite goes into a never-ending loop of some kind. So again, these timeouts in the test settings file should be incorporated as a just prevent the test lasting forever. Now, our tests don't always run smoothly. If you imagine a search website, then quite often we'll type a search string in to a search website and we'll get a message on the screen saying that it's looking for your data, and as soon as it is available, it will display it. So Coded UI has a variety of wait for control methods which allow us to code our test to accommodate these waits for things, where the application puts up a message saying it's not yet ready. We can wait for controls to become available or controls to disappear. We can wait for particular values on controls. And the first one, wait for condition, is a generalized method which allows us to check many conditions simultaneously, to wait on the first of any of several different conditions. So when we're running our tests, when we're manipulating our tests, the UI is likely to change as our test develops, as our application develops, excuse me. And with agile practices, that's quite likely. So it's worth re-recording the affected method. Now, if we limit our action routines to relatively small numbers of steps, then the re-recording is easy. There's not much to do. We just have to position the test suite at the correct position. We can run the test in a debug mode with a breakpoint on the routine that's to be re-recorded. When the application gets to that point, we stop the debugging, but the application is now at the correct position. We can then go into the test recorder and record the new steps. If the method we've created is large and we need to re-record a piece in the middle of it, we've got the UI map editor we can use. We can split the recorded method into 2 or more pieces so that we only have to record one section in the middle, or what becomes now the middle of these different routines. I'm not aware of any way of remerging those methods to bring it back to one method, but it's a good way of changing the recording method. When we've got a larger test suite to test a larger application, it's worth having one UI map file for each screen of the application or each page. Again, with a larger test suite, we may well have more than one developer working on it. So rather than having the 2 or more developers conflicting over their access to the one UI map file, it's worth having a separate map file for each developer. And again, if you have one for each screen or each page, that probably fits well with one developer working on a screen or a page at a time. Limiting methods to a small number of actions is good practice generally because it makes them easier to understand and also easier to do the re-recording. Now you'll seen on the code that's generated, the code I showed in the examples, that it uses long complicated names for the different controls on the screen. We can rename those controls in the UI map editor, and it's probably worth changing names from time to time so that when other people come to look at the test suite, they can understand more about what it is and what its purpose is. It's worth, with coded UI, wondering whether it's worth doing coded UI at all. Some applications are just difficult to test, so we need to know, was testing intended for this application? Was it built with testing in mind? For some applications, testing part of it automatically might be a good thing, but not all of it. Consider an application that generates a report as a PDF file. It's very hard to look inside a PDF file and decide that it's got the correct information in it for your report. But it's relatively easy to drive the application and check that it generates a PDF file. So for your coded UI test, it might be appropriate to check several cases that a PDF file is indeed generated and that all the operations up to and including the generation of the file appear to be correct, but then pass a small number of PDF files to a human to check that their contents is correct. So we're partially automating the application, not fully automating it. Again, we have to consider just the cost of automation. If the test suite is expensive to write, then maybe it's cheaper just to use people to check that the application works rather than automating it. And again, the cost of maintaining the test. Some applications are intended to be changed frequently, and so in that sort of application you don't want to have the test suite continually chasing the application, because you run it once and then the application changes, so you need to rewrite parts of the test suite and run it for this again. So the test suite keeps chasing the application. So maybe that's a case for manual testing of the application. So I've spoken a little quicker than I intended to. So I want to talk just a bit about Testhouse again. We can provide training, more detailed training in coded UI, and also several other aspects of testing using Visual Studio and Team Foundation Server in particular things or in combinations that you might choose. And we can offer them online, much like this webinar, or on your site, or on our own site. Now, Microsoft will fund some consultancy to qualifying organizations, and this is essentially if you've got Visual Studio versions, then when you've got Visual Studio versions, some organizations qualify for getting this consultancy. A small number of companies are providing the consulting days. Testhouse is one of these, and these consultancy days are good for helping you improve your application lifecycle management and the way you use Visual Studio. It's got many facilities, and learning what they are is hard work. so we can help generally with that. And these are some of the benefits of these consultancy funded days. So to find out if you qualify, please contact myself or Melanie, whose address, our details are on the next slide. So that was it for my presentation. I hope you've learned a little bit, and if there's any questions, please let me know.
Adrian.
Hello.
I have a question. This is Jana. It says,
Yes.
in the calculator demos, the numbers are normally typed at the keyboard. How would you data drive clicking the number buttons?
Yes, in the calculator demos, which I've normally used and normally seen, we kind of cheat by typing numbers at the keyboard. But we've got these nice friendly buttons on the calculator. So the way I think this has to be done is you have to record individual clicks on each of the buttons on the keyboard and record each one as a separate method, a separate coded UI action, and then you use the kind of data driving I showed, the command data driving style, to choose which button to click. So if you have a multi-digit number to click, you have to parse that number into its individual characters and then use that to call the relevant, to click on the relevant button, to call the method that's required for that.
Thank you. One other question, Adrian. One of the slides mentioned during your presentation covered adding extra files to the test results. Where are the files stored?
Okay, when you run Visual Studio, tests under Visual Studio, in the solution area, it creates a directory called test results, and assuming that you use the correct names, the default names, then those test result files are named with the date and the time of the test run, and the test result files are stored within those directories.
Great, thank you.
Yeah. Got more questions?
If anyone else in the audience has a question for Adrian, feel free to just put it in the IM window and I can read it off, or Adrian can take a look. But now would be a great time to ask questions.
I'm glad to see a couple of people appear to be typing messages.
Can you see the questions, Adrian?
Yes, just looking at that.
Okay.
Oh, it's... So I got a question here about a particular error message coming out on the Visual Studio 2012 test builder about null parameter name keys. I think I'm going to have to take that one offline. If you could send your email address to Jana or to myself, I'll certainly have a look at that after the event, but off the top of my head I can't think of what that message means. What is a qualified company is another question. Qualified, the fine details of that I think are up to the contract between yourselves and Microsoft, but largely when you buy Microsoft Ultimate or Microsoft Premium, you get, in fact I'm told any Microsoft product, you may qualify for these days, and So you have to, yes, it's the details of your individual contract between yourselves and Microsoft or your supplier of the software. Sorry, can't hear. Yeah. Oh, sorry. And the other thing, of course, is if you ask us, we can find out what qualifying days you have as an organization. If you just email us your details, we can get the results of that. Okay, another question. What should we test using Coded UI? Anything and everything, or almost, not quite. What should we test using Coded UI? It's applications that have a user interface. Coded UI is about functional testing. Does the application or the website do what is required? It's not about performance of it. It's not about the unit testing. It's about, does the application as it exists work? Coded UI runs the real application with no changes, or it runs the real website that you're using. And using interfaces that were designed to help disabled people use the computer. I'm thinking here of sight impaired people have screen readers, and people with dexterity impairments, they have devices that appear to the computer to be a keyboard or a mouse, but have other mechanisms for letting the people use the computer. These mechanisms are used by Coded UI to drive your application. So Coded UI tests the real application. And I'm not sure what you had in mind with the question, what should we test using Coded UI? You can't really check that the layout of the screen is correct. Coded UI is testing the functionality of what's on the screen. It's not particularly checking that, you know, the red bits are red and the green bits are green and the pretty pictures are pretty. It's checking more that the buttons are there, and when you click them, the right thing happens. It's checking that text boxes are there and that you can type into them. It's checking that sort of information. It's checking that displayed values and strings are on the screen and contain the correct values. Okay, how do we add data dictionary, some XML files as deployment items? There's the way I showed in the video. You can add your XML file or CSV file to the solution, to the project solution, so that they are deployed properly. Within your test settings file, you have panels for controlling deployment of files and folders. So that's generally how you look after that. Within the test settings file, you can arrange that files from anywhere on your system can be deployed to the area for the application under test. So, what's this next question? If for one input you expect multiple outputs, how would you put in CVS file? If your application requires, when you say multiple outputs, if you mean it just outputs 2 or 3 values for the one value input into your Coded UI test, then I would consider just having multiple columns or multiple fields within the data source. if your program takes in one set of data and produces several output records, then you could go to a command-driven style, which one command has the nature of this is the data line, and then subsequent 2 or 3 subsequent lines say this is an expected data line, or this is an expected result set. So you have a command-driven style, some commands meaning here is data, and some commands meaning here are results which I expect to find on my screen. How do you verify for one input you get multiple? I think I've just answered that question. Okay. In terms of the slides and getting them, if you'd like to contact us after the event at the emails shown on, I think they're still shown on your screen, to myself or to Melanie, then we'll sort something out on that. Oh, here's a big message. I'm getting the playback failed. Right. Now this is another one of these which I don't think I can answer off the top of my head. If you care to share more information about a message like that, I just spotted the phrase virtualized children in this message. This is commonly because when Coded UI records, I think particularly for WPF applications, sometimes it does not record all of the intervening steps. So you have to arrange to include those intervening, I said steps, I meant controls. You have to make sure that all the intervening controls are recorded. And if you care to email me, I've got some information on ways that that might be solved. So contact me after the session and I'll try and pass that to you. And that's the last question I can see on my screen here. Does anybody else have anything they'd like to ask at this stage? What are common Coded UI error? A Coded UI is good at detecting errors in your application. So it's about functional testing. So Coded UI is good for checking that the correct screens are displayed as you progress through your application or your website. Coded UI can follow, with a bit of programming effort, Coded UI can follow complicated paths through applications where, depending on what data is entered, different screens are shown. So the common errors that Coded UI picks up are the fact that the application is not showing the button that is desired or should be on display. The Coded UI is not showing particular pieces of text. Particular error messages are not being generated by the application at the right time. It's a very general question, that, I'm afraid. What are common Coded UI errors? Coded UI is good at detecting functional errors in your application. Can you verify results by running queries against tables in Oracle database? Yes, I think you can. It's quite possible to have your application working, have Coded UI drive your application to create records in your database, to write queries against your database and display them in your nice application. And separately, but within the framework of Coded UI, you can write methods that send queries to your Oracle database and retrieve information, which you then compare against what Coded UI has observed on the screen of your application. Equally, you could run it the other way about. You could arrange that your test methods send queries to your Oracle database to retrieve information, and then they, in some sense, push that onto the application to make sure it does the right thing. But maybe, rather than running queries against tables, what you need to just think about is data driving the application under test, because maybe the data driving portions of Coded UI do what's required for these queries, this testing you're asking. Next question. Coded UI works quite well with WPF and .NET applications. It is generally good at these things. Sorry, I was just thinking about another slide I've got in a different presentation. Microsoft provides a number of web pages describing where Coded UI works, which applications Coded UI works with, in terms of WPF, Windows Forms, which browsers it works with, and Silverlight, and other third-party controls. Coded UI works with many of these different environments, different programming and application frameworks, but not all. In particular, it doesn't work with Internet Explorer 6 and 7 because they're considered antiques and don't have the right support, and I think there's limited support for MFC, which is one of the early schemes, but Coded UI has very good support for the modern frameworks which Microsoft supply and the modern web browsers. Coded UI doesn't mind what language your application is written in, but Coded UI itself, the test suites, are written in C# or in Visual Basic or in C++. And having said that, Coded UI is itself a .NET application, so once you've got the top levels of your test suite running in C# or Visual Basic or C++, if you need, you can call routines written in any other .NET language to do other aspects of your testing. What are the common runtime pitfalls new users can run into? That's a very wide question. Yeah, I think the thing is just be careful when you're doing the recording. Actually make sure you know what you are clicking and why. In the Coded UI record and generate tool, there's the option for displaying the recorded steps. I recommend every time before you press generate, click on that and make sure the steps that are recorded are the ones you really meant to record. I find it common that when I'm recording steps, I click on things unnecessarily, I click on the wrong things, and particularly when I'm working with websites and recording, I think about what I'm doing, and that happens to be I'm waving the mouse pointer on the screen, and so I get other unwanted things recorded, particularly hover events in the recording. I think another pitfall is trying to do too much in one method. Another one is jumping straight into testing a big application without having done some exploratory work on the small application first, so getting some learning experiences. And so it's worth starting small, but when you do get into testing a larger application, think about the structure of the application. Think about the structure of the test suite in particular. Your test suite turns into a program development exercise in its own right, and you've got all the perils and pitfalls of normal program development work in terms of unstructured programming, in terms of big files which have got just too much in them, and big methods with just too much in them. So you need to think about your structuring of everything. Think about your layout of map files, of UI map files. Start by working with multiple UI map files, and start thinking about splitting the test into multiple pieces. Okay, so is using an assert the only way to verify if the application under test returns expected desired values? Coded UI does a lot of testing for you without you realizing that it's doing that. Before Coded UI can click on a button, it makes sure the button is actually there on the screen. And so there's a lot of implicit testing like that. Before Coded UI can type into a text box, it has to make sure the text box is there. Before Coded UI can visit a menu on the screen, it has to make sure that that menu is there. So there's all these implicit tests for you. In terms of asserts and things, basically the assert is the way to go. Now there's two ways of generating the asserts. Either you can use the Coded UI test builder and generate an assertion via the methods of the test builder, and remember that you can assert for multiple things within one method. So if you've got a screen on display, it's quite possible to generate assertions for 2 or 3 or so fields on that one display, on that one screen, and put all those assertions into one Coded UI method. The other approach, of course, is writing it yourself, and basically the assert and its various methods are the way to check that something has passed or has failed. You can write an if statement, if and a condition of your choosing, and then call assert.fail. Recall how in the expected failures demo I did, in the switch statement on the default path I just called assert.fail. The testing was done in my conditional code, and the assert was just an assert.fail to give a message if that part of the code was reached. If using Microsoft Test Manager, do you suggest starting with an action recording via MTM or start directly in Coded UI? If you've got an action recording from MTM, then I would use that. If your action recording is a useful, good test of your application, then I would recommend using that and converting that into a Coded UI test. But remember, when you run the test under MTM, the test will pause periodically, expecting you to check that what is on the screen is correct, and then click pass or fail accordingly. Now in the coded UI version of that test, after the automatic translation, there will be no checks like that. If you just convert it and run it, the test will probably pass. It'll run very quickly through the actions you've said and say, I've done all those actions, I was able to do them successfully, pass. But it will not have done any of the checks that you wanted. It will not have validated any of the screen contents or anything. So you have to add into that test assertions at various stages that things are correct. Now, one way of doing this is if you run that test under the debugger, and then either by using breakpoints or by using, I forget which key it is now, the step over command, you can just step from method to method through your test, and then when your application gets to the correct point, you can start recording the assertions using the code and generate tool. You have to stop the debugger before you can start the code and generate tool. Yeah, essentially what I'm saying is you're driving the application to the correct state, and then you create a test. Now you can drive the application using the coded UI test, or you can manually run the application to the correct stage and then just record the test at that point. So how do you, I beg you, I'm skipping a question. Question about an object on the screen that was moved after recording the test. So if a button was on the screen was moved, what happens? Generally speaking, if the application just has minor layout changes, just moving things around the screen a little bit, then coded UI will accommodate that, because coded UI works by searching on the screen for the particular button or whatever. It expects a certain kind of hierarchy of controls, so our buttons go within panels, which go within panels, which go within the application, which goes on the desktop. So coded UI expects that containment structure, that hierarchy, to be approximately correct, and if that hierarchy is maintained, then coded UI will probably find the control even though it's moved, and therefore your test will continue and not fail. Coded UI is designed to operate in that environment where it doesn't where it doesn't fail on those simple changes. Coded UI is about the function of the testing, the function of the application, not about the pure screen layout. But if coded UI can't find the button, for example, then it will report a failure, that that button is not available, and that particular test case will be failed. So next question, how do you convert an MTM to coded UI automation test? When you run the coded UI record and generate tool, it first comes up with a window saying, do you want to record and generate, or do you want to use an existing recording? So this can come in, I think, two cases. If you create a new test case, it will produce that. Yes, when you create a new test case, that window will be displayed. So one option, yeah, I beg your pardon. When you create a new coded UI test, it will pop up that window, which has two options on it. One is to create a new test using the coded UI recorder and generate. The other option is to convert an existing recording. So you just click on that convert an existing recording, and then coded UI pops up a window from MTM containing your recorded tests, and you can browse from there to find the correct recorded test. Just click on the test to be converted to coded UI and click OK, and it very quickly codes that up as a coded UI test. And it looks very similar to the tests that I showed earlier in this presentation. So each of the steps in your recorded test come out as an action in the recorded in the coded UI test. This action recording could be data driven, and if it is, then coded UI will generate a data driven test to use that same data. I think this is not a question, this is a helpful statement. We're reminded that coded UI finds the control by using the attributes of the control, and these attributes are set in the UI map. Thank you for that reminder. How similar is coded UI to Hewlett-Packard's Quick Test Pro? What are the major differences? I think we have to take that one offline. If you care to send an email to us that, we'll think. And well, that's a wonderful lot of questions. Thank you for all of that, and thank you to everyone who's been listening. And I think we've gone a little bit over time now, so I think we have to call it a finish now. So thank you very much, everyone. I hope you've enjoyed the presentation. I hope you've learned a little bit about coded UI. Thank you very much.